Welcome to our third video in the series, and this is going to be our quick start to MDE-DevOps. We're going to show a practical example of Epsilon being used with CI/CD practices. In this example, we're assuming that you have some background knowledge, that you're familiar with MDE, the Eclipse IDE, in particular Ant and the Eclipse Ant Runner, that you have some knowledge of Epsilon, one of the many modeling tools available, and that you have some experience of Git version control, be that through GitLab or GitHub. This example will use GitLab, and in particular we will be looking at GitLab CI pipelines, where we will be using Epsilon as our modeling tool and executing Epsilon programs within the CI pipeline to perform modeling tasks. So consider the process of bootstrapping an MDE project such that you can turn your ideas into models, into products. There's the initial setup of the development tools. In our example, we would consider this to be the installation of Epsilon and the Eclipse IDE environment. There's then the need to set up the Git version control repositories. We would then need to create an initial set of project files. We might do this, for example, using the Epsilon playground, which would give us a quick way to start developing a modeling language, model, and a series of programs. Outside of that, there are other non-technical things that would need to be considered, such as what is our change management process as we evolve the model? What known specifications and requirements are there for the validations that need to be taking place on our model? And who do we need to provide reports to as our project proceeds and runs over a period of time? This is the abstract view of a modeling project, where we can see a number of development cycles. These cycles are dependent on languages and models being validated, the results of the validation being reported back to the relevant team members, such that they can then make modifications to the relevant component, be it the language or the model itself that's at fault. Similarly, in later stages of the project, there'd be automated processes, such as the generation of code, which would be subject to testing. The tests are going to indicate where there are errors within the code that's being generated, and this information would need to be fed back to a transformation modeler who may need to alter the generation process. Ideally, we would like these processes to occur frequently as changes are made within the project's lifecycle, and this is where the CI/CD approach can support our modeling processes. So for anybody that's jumped straight into this video and hasn't seen our previous videos, the example project that we're using has come from the Epsilon playground, where there are 3 example projects based on a Java state machine. The project that we'll be using is a combination of 3 of these projects brought together such that we have a program that performs a graph visualization of a model, produces Java code from the same model, and a validation that checks that a few rules have been adhered to when creating the model. These 3 Java state machine projects have been combined in a way that enables us to have multiple programs being executed against a model as if it was a larger MDE project. Here we can see the playground example that we've been using in previous videos. This is the Eclipse IDE, and on screen we can see the build XML file, which executes the 3 programs against our model, which is defined in the model.flexmi. And on the right we can see the GraphViz representation that has been generated of this model. We also have generated Java, which has been produced by the Java program.egl. And these are all produced through this one build XML file, which loads the model, executes the validation. If it successfully passes, then execution continues to the Java generation stage. And then if that passes successfully, we generate a GraphViz representation of the same model. This build XML then disposes of the model and refreshes the playground example folder we've got open in the Eclipse IDE here. We can perform a run and we can see here validation passed successfully, and we get a graphviz.file and similarly a Java generated.java file. So for this example, I have taken those files and uploaded them into a GitLab project space. And at this stage, we would be considered to be playing under the Git rules, where everything is now version controlled. We could be using a local IDE and pushing and pulling to the Git repository, or, as we will see later, there are IDEs available within GitLab that can also push and pull to the repository. Everything in the modeling project is now under version control, which is to say that any changes to the modeling language, model, or programs which either perform transformational validations are going through a Git version control process, meaning that it is now possible for us to document our changes and revert them if necessary. It is also possible to use other Git features like branching and merging if required. So let's have a quick overview of a GitLab CI pipeline. GitLab provides the CI pipelines to run processes on projects in the GitLab cloud. A script is provided in a gitlab-ci.yaml file, and in this we describe the processes that we would like to perform on our code base in the pipeline process. The CI pipeline can launch Docker containers with any tools that we require to execute the stages that we've outlined in our pipeline process. The Docker container that we'll be using has a full Eclipse IDE installation with Epsilon tools installed such that we can run Epsilon programs against the models that we provide in the Git repository. When a container is brought online to execute a task in the pipeline, the Git repository is attached to that container such that we don't need to struggle to try and get our files into the container to execute programs on them. Once the container has finished executing, it is possible then to review the results of any tests that have taken place or to export any artifacts that have been created. On screen we can see the MDE-DevOps _example project has been created on GitLab, and we have uploaded our Epsilon example project files, and from here we will now be able to create a CI pipeline, and to do that we can use the editor that is available online. We go to the Web IDE, we get a Visual Studio editor interface that we can now see all of our project files that have been uploaded, including the GitLab CI YAML file which has been created, and an additional set of build files we'll explain in a moment. So the GitLab CI pipeline is instructed via this file, and the typical layout is a series of stages that will execute one after another. Each stage can have one or more jobs. Stages are defined in sequence at the top, and our jobs are declared first with a name, then stage to indicate which stage this job belongs to. We need to provide a Docker image for our Epsilon programs to be executed in. We are using the Epsilon CI container provided at the URL that we can see here. And this container takes a parameter set that defines the ant build file that should be executed and the stage within that ant build file that should be executed. This container has a full Eclipse IDE installed with all of the Epsilon tools. However, the GUI is not accessible whilst the container is being used within the pipeline. Thus, the only way to control what happens within that container is to provide an ant build file. Our original example, we created this ant build file, which has the 3 Epsilon programs we need to execute against our model, configured in a sequence of stages that require a validation to pass before a program can be generated or a graph. However, to create an equivalent setup in a CI pipeline, we now need to use the GitLab CI file and take our 3 steps and arrange them as separate stages. Each stage will have the single job of executing a build XML file for that stage and job. And for this reason, each of the XML files listed here have been added to the project so that only one of the programs is executed when a build XML file is called. So validation has been separated out, as has the Java generation and the graph. To trigger the pipeline to execute, we simply need to make some change to our model or one of the files. Let's deliberately insert an error into our model and commit that change. This commit has gone back to the repository. We refresh. We can see our commit has initiated the execution of a CI pipeline, which is now following the script that we've prescribed. And as we watch it execute, we can see each of the stages with each of the jobs. We click on the job. We can see the console as this job executes. We scroll through the console output, back to the top. Above all of the noise, we can indeed see the build failed, with our validation detecting that one of the state names has more than one character. We go back to our pipeline graph. Refresh. We can see that the validation has failed and that the further stages have not been executed. But let's correct the problem. Again, we commit back to the repository. Go back to the main project page. We can see our commit has come in. And we can now watch the pipeline execute in real time again. This time the validation stage has passed. The container is now being restarted, and our script is passing in our graph build XML file. By splitting out into 3 individual build XML files, we will clearly see on a graph like this which stage it is that's failed. And we can then immediately go to the error logs relating to that task's failure. However, if we simply loaded one ant build file that performed all 3 tasks and it failed, we wouldn't know if the problem occurred in validation, graph, or Java. We'd have to then go into the error log to find out which of the 3 tasks has failed. So to summarize the demonstration, we've seen that we can automate the execution of Epsilon programs in a CI pipeline using ant build files. We have a full Eclipse IDE installation with all of the Epsilon tools being controlled using ant build in a Docker container. Without needing in-depth knowledge of ant build, it is possible to create a basic pipeline with simple tasks outlined in ant build to execute a single Epsilon program against a model. Each execution will report back to the console that can be viewed within GitLab CI. Validation programs will be reported into the same console. If we are executing a generation that produces another file, we can export that using an artifact. This may not be the most optimum way to manage your project, with many ant build files creating an overhead. However, consider the fact that the ant build file will be executed many times for the single time that it will be set up. So an alternative approach would be to create a monolithic Ant build file, which switches context based upon a parameter being passed in. This does add some additional complexity to the Ant build file itself. However, it does enable a single Ant file to be managed that can then be used across multiple projects. In this example, we've set up an Ant build which will switch between a number of Epsilon programs based upon the CI job being executed. The name of the CI job is used to select a model task, which then has the parameters required to launch the relevant Epsilon program to perform its task, be this graph generation, validation, or Java generation. This is only one proposed way that you could switch between various tasks within Ant build. I've adjusted the GitLab CI YAML file for our example project here, such that now we call a single monolithic build.xml file, and we will pass in an environment variable which will report the job name to the build.xml file that's executing. If we have a look at the monolithic build, we can see that our workflow will begin based on the target name, validation, graph, or Java. Each of these targets will then call the workflow. The workflow is responsible for loading our model and then performing a call to the relevant function, which will then execute the Epsilon program with the relevant target parameters specified and against the model that's been loaded in M as usual. And then upon exit of these functions, target product here is responsible for doing the refresh, and we will dispose of the model and exit. This build.xml file is somewhat more complex than our previous examples where we had a single program being executed in a build.xml. However, we could reuse this build file across multiple projects which would share similar workflow patterns of performing a validation, graph, and Java generation. In our demonstration, we've shown two different ways in which you can organize the Ant build files with relation to the CI pipeline that will be executing them. However, what other things do we need to consider when we're automating our MDE tasks using a CI pipeline? Well, the characteristics of the CI pipeline that we're using can impact on how the reporting works. In the case of the CI pipeline within GitLab, our reporting is by job and stage. As such, if we stack several tasks into an Ant build file, then only a single job report is generated for all of the tasks within the Ant build file. Therefore, if we wanted to divide these between different individuals, we may need to separate the tasks into different Ant build files, which can be allocated to different jobs and stages. The second thing to consider is the size of the model and the number of tasks being performed. It is possible to execute multiple jobs in a single stage in parallel. Therefore, it would be possible for us to run several validation processes in parallel, and only if all of those jobs have executed successfully would the stage complete and the following stage proceed. This makes it therefore possible for us to reduce the amount of time that it could take to validate a model. This is not necessarily applicable in all cases, as it may be the case with generations where the product of one stage is required for the following, and thus it won't be appropriate to necessarily turn generation processes into parallel executions. However, there may be opportunities in some cases where a generation results in an end product that this can be done. As a byproduct of this movement towards a GitLab CI pipeline, we've also gained an added benefit in the fact that we can now work solely from GitLab itself. So if we have problems with domain experts using the Eclipse IDE, we could take the opportunity to present to them the GitLab VS Code IDE instead. This means that there's nothing to install on their machines and they simply need to use a web browser. At the time of recording, the plugin extensions for VS Code in GitLab are disabled. However, there is an Epsilon plugin which would enable full syntax highlighting. So once this feature becomes available in GitLab again, it would be possible to use that plugin and have the full syntax highlighting within VS Code for all of the Epsilon languages. So far, we've seen MDE-DevOps being used with Ant and the Eclipse IDE to execute Epsilon programs. Over the life cycle of our MDE project, we can change control all of the changes to the modeling languages, models, and tasks using Git. And as commits come into our Git repository, we can execute a CI pipeline, which executes the model management processes or programs against our model. Using the feedback from these processes, we can then make corrections to the model or evolve it further. The CI pipeline uses the Epsilon and Eclipse IDE installed within a container, and the only way to operate these components is through the use of an Ant build script. In many cases, the output of our MDE-DevOps operation will end in a code product. These code products can then be tested using the normal CI/CD practices. For instance, if you were using the Java language, you may have a series of JUnit tests that you then execute using a CI pipeline. The code that your model has produced can either be compiled into a binary format and then released to developers as some form of library that they could import, or you may simply export the code direct to them. It is possible that you can have a CI pipeline published to both a package registry within GitLab or push to a different project altogether in the GitLab space. However, at this stage, we are starting to head towards standard CI/CD practices, which there are further examples online that can be found that will explain what can and cannot be done. Our next video provides a technical dive into how the container was created and how we might look to create other containers for MDE tools that are based on the Eclipse IDE. It is possible to use and build with other MDE tools such that they could also be automated in a similar CI pipeline.